hours will give you the insider knowledge. And trust me, you will hear from well-seasoned industry professionals to gain insights on how to accelerate this journey. And so, welcome to what I believe will be a career-defining moment for every one of us. So, I'd like to just go on to the agenda slide. Let me walk you through exactly what we've planned for the next 2 hours. I will do a brief introductions to Energy Institute and our West Midland Young Professional Network. And also, Christabel will be providing an overview of Energize Black. And then we move on to the quick fire audience engagements, more like a warm-up. And Kojo will run through the first session and the Q&A. And then we'll listen to the second session from Richard and his Q&A. Each of these Q&A sessions will run for just 10 minutes, and that will have an interactive breakout room activities that helps to stimulate our thinking and networking, after which we then move on to the feedback to reflect on the key learnings and takeaways. But if we still have more time, speakers might be able to respond to more questions, and after we've taken our event pictures, we just close for today. Yeah, so let me just share few guidelines to ensure that we have a seamless and distraction-free experience. Please keep your microphones muted throughout the session unless we specifically invite you to speak. Feel free to use the chat function to pop up your questions, as each of the speakers will address your question during their dedicated Q&A session. And but due to time constraints, we may not be able to answer all questions live. But bear in mind, unanswered questions will be addressed in the comprehensive post email, and you'll be receiving that. Uh, Also, it's important for me to tell you that this session is being recorded, and by remaining in the session, you consent to being recorded. So recordings will be shared with registered participants. Now we are all set. Let's get started. So before we dive into today's AI and energy discussions, let me just briefly introduce the Energy Institute, one of the organizations that has made this event possible. The Energy Institute is the chartered professional body for energy industry, and for more than a century, they've been at the forefront of energy innovation from the oil and gas era through to today's renewable revolution. They inspire, they influence the global energy community to enable a more efficient, safer, and even to decarbonize the industry through creating best practices. So they achieve this through this event like this. They conduct professional training and development courses through their technical expertise to bridge the gap between what energy is today and what we're heading tomorrow. And one of the courses is the AI in the energy sector, which is quite similar to what we're talking about today. It's a self-paced online course. They do it through case studies, practical examples, structured learning, and that would help to get you to gain insight into the challenges, the opportunities, and the transformative potentials of AI in this modern energy environment. So please, in case you're interested in this training and development course, the link on this slide right below here will navigate you to the website to see more information. I'm also happy to paste this on the chat. So, now I'm going to be touching up on the West Midland branch of Energy Institute Young Professional Network, which was launched less than 1 year ago by our chairman, Abdulhamid Raji. And you can all see that since then we've grown, and we've really gained momentum from face-to-face events to webinar. This is our fourth event in less than 1 year. And through this EHI Young Professional Network, platform like this, like our West Midland chapter, which is co-hosting these events today, kind of connects emerging talents with industry leaders and cutting edge opportunities. So the EHI is really committed, is one of those beauty about EHI. It's committed to developing energy professionals at every career stage. And bear in mind that joining to become a member of this EHI has several benefits, most especially for students. You can have shopping discounts. I'm not really talking about the groceries from Tesco and Asda's, but I mean free access to e-libraries, discounted rates for technical publications and EI events. This is not just about benefits for students alone. If even if you're not student, if you're not a student, I mean you can enjoy EHI events. I mean, it's International Energy Week, which is the flagship conference. You can also have the potential opportunity to contribute as well and even become a committee member. So at this point, I'll be handing over to Christabel.
Yes, definitely. Thank you so much, Jalilat. You've made EI sound exciting, and now I hope to make Energize Black as exciting as as you've made EI sound. So, hello everyone. We are Energize Black, and we are largely dedicated to creating a transformative community where Black professionals, but not only limited to Black professionals, but where underrepresented groups in the energy sector can thrive and contribute to the industry's growth and innovation in the UK and beyond. And so for us, we through empowerment, collaboration, and a commitment to excellence, we are contributing to the UK's diversity and inclusion in the energy industry and in the workplace as well. We've grown so much and so fast. At the moment, we have over, well, I think over 600 plus members in Energize Black, and they cut across different backgrounds and countries, and we across Africa, Europe, America, and we're so proud of the work that we're doing today and the impact that we are seeing through Energize Black activities and engagement. So just for us, we have three major thematic areas, and these are what we call Get Hired, Swift, and Collab Quest. And each team has um, different activities they perform. So Get Hired is mostly dedicated to preparing and matching talents to job opportunities. They offer market insights and offer guidance as well on employability skills such as interview techniques, CV writing, etc. Swift is dedicated to training and upskilling. And so you'd find that we have several training opportunities, training workshops, webinars like this. And so we're bridging the skills gap in the energy industry by engaging with so many institutions similar to Energy Institute and so many partnerships across to make sure that we deliver a comprehensive training program. And then finally to Collab Quest, which largely focuses on boosting dynamic networking in our community and mentorship as well, and just basically uh, just putting the community and its members in the spotlight and in leadership positions whenever we can, whenever and wherever we can. And so we've seen huge results in the few months or uh, say about a year, and we're proud that we have collaborated as a team to plan various events, train so many professionals, support people with mentorship, interview prep, etc. And we are looking forward to continue to make impact in the coming years. Thank you. Right. So, moving on to what the today's webinar and the purpose for which we are here. So we're going to hear about AI, But before we do that, we want to get a general understanding of you, what you think about AI, what you're not, what does AI mean to you, how you feel about AI in the energy industry. So at this point, I will implore you to join this just open Slido on your phones, on whatever gadgets or device, and let's just have, some quick fire polls. You can just scan the QR code and we can start with the activity. I'll just give this a few seconds for everyone to get set up. Okay, so Slido's open. You have the first question. How would you describe your current AI knowledge? Okay, so it seems like at the moment we have a number of people, or most people are just starting to learn about AI with limited knowledge. Okay, right. Okay, awesome. Looks like that is still the case. And then we have a lot of people that are also learning actively, and some are consistently working with AI at their workplace and in their personal lives. Awesome. Um, right. So next, let's see. Feel free to put your own answers here. What applications of AI do you think are currently impacting the energy sector? So there are various applications. I mean, ChatGPT, there is machine learning, AI with machine learning, etc. Just type, okay. Okay, awesome. Like what's coming in so far. Interesting. Um, it's great to know that people have identified a lot of these applications that are impacting well, the energy industry and the world at large, to be honest. All right, I'll just give it a few seconds. Let's see what more come in. Okay, awesome. Thank you so much for your inputs on this. This gives us great context, and especially to our speakers, it certainly will inform them of what people think generally about applications of AI. And finally, to the final poll, which area in the energy sector do you think AI will transform the most? Awesome. Liking, liking the answers coming in. It's amazing, the answers coming in. And I'm trying to see with the first question where people said they're just starting with limited AI knowledge, but these answers coming in do not exactly correspond to that. It seems to show that a lot of people are up to date with AI applications, and that's amazing to see. All right, I'll just give it a few seconds. Okay, awesome. Thank you so much. And so this, creates sufficient context for our speakers. And so on the topic of speakers, let's just see. Let's move on to meeting our speakers for today. So, I mean, you've probably seen the publication, the on social media, LinkedIn, who our speakers are, and you already know them, but yeah. First, our first speaker is Kojo Appiaje. He's an AI consultant and researcher at Energy Systems Catapult, and he is championing ethical and responsible AI across different sectors in energy, in digital applications, etc. He is advising on AI applications to decarbonization and policy, and also is very supportive in Africa, supporting African policy makers in developing their digital and AI strategies via Kala in Nairobi, Kenya. And so it's amazing to have Kojo with us today as a speaker. Next is Richard Yen Ting Chen. He is a data, AI, innovation, customer excellence, specialist. And he's worked across various sectors from IT, wind energy, and maritime to Microsoft and now Admirals. And he helps developers and stakeholders unlock the real value of data, AI, and other emerging technologies, turning innovation into impact. So we are extremely happy to have Richard with us to share his AI knowledge and experience with us. And so without further ado, I will hand it over to Kojo for our first session. Feel free to share your screen, Kojo.
Hey, good afternoon. Just checking you can see my screen and hear me okay?
We can hear you. Can't see your screen yet, I think. Oh, now I can.
Oh, okay. It's okay.
Yeah.
All right, brilliant. Yeah, thank you for welcoming me. My name is Kojo Appiaje. I'm an AI consultant at the Energy Systems Catapult. What the Energy Systems Catapult does, for anybody who's not familiar with us, is look at accelerating the policies, technologies, businesses and research which is necessary for moving us from our current point to a net zero future. And within this mission, I shape the adoption and use of responsible AI. So I work with policymakers in the UK. I work with academics, with businesses, and with researchers, and kind of at that next point as well of also connecting those different groups. And as I mentioned earlier, I also do quite a lot of work in the African AI space, working directly with policymakers to help shape Africa's AI strategy and policies, particularly around harmonizing across different countries. So happy to talk to that if anyone have any specific questions around it. In terms of today, so what I'm going to talk about is AI as a catalyst for net zero, and focusing on practical applications and a bit on governance as well. I do have a slide on if people are interested in using generative AI in their own workflows. So I tried to tailor this to different experiences, and I'm kind of glad when we did the poll initially to see such a range of experiences, and especially seeing people start off on this journey who might not know a lot. But my hope is you leave this session at least knowing more than when you started, and definitely in terms of applications, was really happy to see so many different applications come about. So I hope that you can pick up on a new one that maybe you weren't already familiar with. So there are three big broad challenges that I see in the energy sector today, which center around unpredictable supply and demand. So forecasting renewable energy generation, forecasting energy demand and markets is a very difficult task to do. There's grid stress and hidden assets, which is basically in the UK that, well, this is a global issue, but in the UK specifically, the energy grid was, developed in the 20s and the 30s and then evolved in the 50s. It's incredibly old, which means that now as we make it much more complex and add on additional assets, so like solar generation and EV chargers, EV vehicles, you're going to hear me talk about like some of these examples a lot throughout the presentation, that the grid struggles to keep pace with some of that additional load, and we hit congestion when the grid cannot take extra electricity generation and move it to sources of demand. And this is very much a poignant issue, especially in low and middle income countries, where the transmission grid is even more stretched and not as robust. And then the final big challenge I wanted to highlight is all around planning and investment hurdles. So this is struggling to know where to site energy generation, where to deploy EV chargers, and the fact that developing new transmission lines is very capital intensive, is very expensive, and it's uncertain. In the UK, again, when you are developing new transmission lines, well, really anywhere, you need to talk to landowners, you need to talk to the local authorities, you need to surmount like regulatory hurdles to prove that what you're developing is going to be safe and is also necessary. So there are a number of barriers which kind of prohibit the development of new transmission lines, which is why we're looking at AI as a way to kind of coordinate what we currently have. And for me, I look at AI primarily through the lens of efficiency and coordination rather than invention. Invention is necessary, but really we're talking a lot about coordination. How can we do more with what we currently have? And that's what I'm hoping some of the applications especially will speak to, these three different challenges broadly. But I want to start off by really acknowledging the elephant in the room. Isn't AI cooking the planet? Data centers require a lot of energy. Generative AI in particular requires a lot of energy. So I wanted to first set off by acknowledging that, but also clarifying that typically, at least in my role, when we talk about AI in the energy sector, we're not necessarily like focusing on ChatGPT and generative AI. Like AI as a field has existed for many decades and has also been quite active in the energy field for many decades. So when I'm talking about AI, I'm also talking about machine learning, which is broadly teaching AI to recognize, to firstly feeding it data, then teaching it to analyze that data, recognize patterns, and make predictions. Deep learning, which is the next step of that, which is almost like layering machine learning, like algorithms on top of each other, in some way like mimicking what is supposed to be the structure of the human brain. You don't need to pay so much attention to the information on this graph here, but I wanted to highlight just how big this field is. And then also large language models, which are captured in the generative AI section at the nucleus further down, is a small section of a much, much bigger field. Yeah, it's important to kind of recognize how diverse and wide this field is. So yeah, generative AI models do have a significant impact, particularly around training. ChatGPT required like 1.3 gigawatts of electricity over 34 days to train, which is something like the equivalent of 120 average US households, their energy consumption in a year, which is intense. But again, these are systems which are now being used across the globe. So it's almost hard to recognize what their impact could be in other facets of life and of existence, how they are improving different workflows, but yeah, they do require energy. And I think I will come back to this point, but the main thing I want to stress around generative AI use is always just intentionality, like use it with intention. My manager loves to talk about people that are making like tons of like images of cats, for example, generating images of cats, videos of cats. The internet loves cats, but not the best use of energy, I would say. Starting with the first use case I wanted to talk about, which got mentioned quite a lot in the polls, forecasting. So this is looking at AI to improve energy demand, weather, and generation forecasts through better modeling, through like more data, through more advanced algorithms, and that to the point where you can give an AI information on sort of this is where our current this is basically trying to predict the weather a day in advance or a few hours in advance, which is something which is quite difficult to do. But with the more advanced algorithms, you can do that a bit more easily. Um, and the benefit of this is it reduces curtailment and procurement, because you can make more accurate forecasts of what energy demand is going to be or what the weather is going to be, which is important because with renewable energy sources, so typically, solar for PV, and wind for wind turbines. Um, those sources of energy are not consistent. The weather's always changing. Sometimes you will have more sun, sometimes you will have more wind. So knowing how much sun or how much wind you will have then determines how much, for example, energy you need to have in reserve, like how much you would need to rely on fossil fuels or how much you would need to rely on other sources of energy generation. If you can make better predictions on what energy you can generate, then you no longer need to do things like pay for wind turbines to stop running because you have an oversupply of energy. Um, so doing this, obviously improves costs, and those costs like compound over time, which means they can be reinvested into developing the grid, which again, I will stress is really important for low and middle income countries where there's not a lot of revenue that goes into investing and improving the grid. These are some ways where we can do more with what we have to save more money in the long run. NESO, which is a UK system operator, in collaboration with an organization called Open Climate Fix, developed a tool called solar nowcasting, which is just a way to forecast in much more immediate timeframes, and further timeframes, and improve like solar and wind forecast accuracy using deep learning. The next use case I wanted to highlight is around flexibility. This is looking at AIs orchestrating the millions of devices which are on the grid. So you're talking electric vehicles, heat pumps, home batteries, solar generation on rooftops, all of these different assets, which some provide energy to the grid and some obviously increase the demand on the grid. Coordinating all of those things is quite a complex process. But we're seeing AI being really useful for turning, I put households here, but I would stress like it's the assets broadly, like turning those into things called virtual power plants, VPPs. And VPPs don't just operate on a household level, but also on a local area level, on a regional level, where, say, if I have an EV vehicle and so does Christabel and Juliet, and we all have these different assets, if we're on the same tariff, the example here I've highlighted is Kraken's Intelligence Octopus Go. Kraken can then offer our assets or offer the capacity of our assets to the system operator as being able to participate in flexibility. So that if, for example, NESO says, we have an overabundance of energy in this area, can you take it? That might be the best time for then Kraken to signal us, this is the time to charge your vehicles based on like this time period. And then that's how our vehicles and this wider VPP can participate in flexibility, because we can respond, and I say we, I stress again, it's the operators can coordinate some of that capacity. So with Kraken, their Intelligent Octopus Go tariff provided 700 megawatts of flexibility to the grid. They said this is more than 160,000 connected electrical vehicles on this tariff. And it ensures that customers only charge at the very like cheapest or greenest times, and it takes extra pressure off the grid, and reduces consumer costs and increases overall grid stability. And ensures that end users essentially that they get to choose. You choose when your car charges and to what extent you get to choose, if like to what degree you participate in some of these systems. It's not necessarily by force that if you're part of this tariff, you have to charge your car at this time. You can't charge your car at this time. It's that element of flexibility that I'm talking about, where it doesn't matter to you if your car charges at 11 p.m. at night or 2 p.m. at night or 5 a.m. in the morning, then why not participate in these markets? And I think this is what AI is helping us do, is helping us manage this complexity, because it's just not feasible or possible for a human to be at a computer kind of matching and offering some of these services across hundreds of thousands of devices. And this is only going to get more and more complex as we add more and more devices to the grid. Another example of AI flexibility I want to highlight is battery optimization. And this is specifically here where I'm talking about battery operators using AI to execute autonomous decisions in response to like market signals. So which is very useful for increasing asset revenue and supporting grid stability. NESO might send a signal that we need X amount of capacity to dispatch right now in this area. And it's usually you might have a person or you have a model which will make that decision on whether to participate or to respond to that signal. But with AI, you can have your battery participate across multiple different markets, respond to different signals in unique ways. And Arenco is one startup, a UK startup I highlighted, who they've been able to generate over £1 million excess revenue per year for every 50 megawatt battery that they have compared to the market average. They have a platform called Nimbus platform. So if anyone's interested, you can search that. But it's because there are multiple levels of stacking revenues for batteries that there are different markets, it's helpful that you can kind of build these algorithms to respond in different ways to different markets that you might want to participate in and might not want to participate in. And responding in real time to those signals is a very tricky thing to do for a human. So this is another way we're seeing AI be really useful for wider flexibility. Let me see if this plays. I'll just keep this on mute. Another example I want to highlight, and probably the last big use case I wanted to highlight, is AI is being useful for siting and planning of energy infrastructure. This example here is from NVIDIA, specifically focusing on wind farm layout optimization. Wind farms, which I didn't know. I haven't been at the catapult for very long, so I found all of this incredibly fascinating. As Jelly has said at the beginning, very much interested in the sector. It is progressing at an incredibly fast rate. But wind farms, I think innately I had an idea, you're just putting turbines in the ground. It doesn't necessarily matter. You just get them in the ground or get them in the sea and then let them generate the electricity that they need to. They can be very difficult to get optimized. You don't want to have, turbines blocking other turbines in terms of the wind that they generate. It produces this wake, right? So turbines further at the back will not receive as much wind as turbines towards the front, potentially. So if you're not intentional about where you then site those different turbines. And this is from videos talking about the way they've kind of simulated and modeled different environments to figure out how you can maximize the efficiency of each turbine generating as much electricity through receiving as much wind as possible. Obviously increasing yield, increasing the rate at which owners and operators can then finance these projects and pay back these projects and make money from their investments, and that increasing yield at which we can generate electricity from these assets. EV charging and deployment is another one I want to highlight here, as being able to identify the best locations for demand and grid access. Knowing, for example, just where to put an EV charger. Like you want to put it towards your population centers because that's where people are going to be. However, that doesn't mean you can then ignore rural populations. Where do you then site EV vehicles in terms of travel destinations? You want to put them on motorways, but where do you put them on motorways? Things like this are quite difficult to know innately how to maximize your investment and maximize decisions. And I think, one example I've seen is people stacking different sources of data on top of each other to help inform those decisions, and using AI to then make recommendations that you can work with. For example, like looking at simply like some Google Maps, like looking at what routes are particularly popular in terms of drivers navigating, looking at population data, like where do people typically tend to congregate, especially like areas of traffic that might build up on the motorway or certain roads. Working with local authorities as well to highlight areas where they think it might be helpful for EV vehicles to be deployed. These are all just different ways of stacking data on top of each other and working with a model to help inform that decision. And then finally here, transmission planning, again, going back to the point of simulation, like simulating transmission planning over different circumstances. So looking at population growth, looking at, for example, who owns land, looking at the types of land that you might have to dig up to replace infrastructure to build new transmission. These are all things which can become quite complicated that AI does make a lot more simple and accessible. And then broadly, other applications, this is just a mishmash of stuff I wanted to mention before moving on. AI in the control room, so the control room of NESO and other system operators, but also internationally. In the Netherlands and France in particular, Tenant and RTE respectively. Their transmission system operators are quite very much at the forefront of using AI in the control room. Still in pilot research and development stage, but very much seeing this as the future for managing some of that additional complexity on the grid. So AI is supporting congestion management, making informed decisions on when and where the system operation redispatch or and how to reduce constraint costs. Things like dynamic security assessments, so monitoring the stress of the grid, asset monitoring, which is making like predictive maintenance for aging infrastructure, highlighting where certain systems may be at risk of failure, so you can anticipate a breakdown and fix that before it happens. API and data standardization. So this is enabling different assets to speak to each other. If I have a particular EV vehicle and Chris has a particular EV vehicle, why are we able to charge at the same charging infrastructure? It's because of this interoperability that we can both go to Lidl and then shop here for anyone who's not aware, the supermarket for anyone who's not aware, and then charge our cars at the same infrastructure, even though it's not branded for any particular car. And this is due to something called the Open Charge Point Protocol, which is, really useful for being a general standard in the industry for communication with EV vehicles. And here's where AI can be very helpful, because you also see AI being used for predictive maintenance through like pattern recognition of charger behavior, knowing, say, if the electricity flow is fluctuating at a rate which is abnormal. And also just being able to, adapt energy optimization so you can charge vehicles at different rates. All of this has been a really powerful application of AI. Market monitoring, so spotting a risk in the markets where you might have like AI agents colluding with each other or manipulating the markets. This is where you can find AI being used for as a defensive measure for spotting AI being used offensively as well. And then carbon tracking and reporting, so using AI to measure and monitor the impact of carbon emissions. I think I'd also add large language models as being quite useful here for reporting, because it's very helpful to have an AI which can then translate some of the deeper analysis that a human might not immediately recognize as a problem, to translate that into language that human can then act on. So these are, again, ways that I think you can actually combine an AI which is doing one task with another AI doing another task. But why is this not? Why have we not seen AI everywhere? Like at this point, if it's doing such great things, I wanted to highlight three big challenges that the sector is facing today, which is data availability and sharing. Data sets that we are currently still quite siloed, even though the UK is very much a leader in sharing data. The Energy System Catapult led a big project for Ofgem and the government, looking at making energy data more available, which we produced a report on, and we had one of the principles in that was around data being presumed open, which is that which recognizes if the data doesn't violate commercial or privacy constraints, then by default it should be open and should be shared. Limited interoperability, so this goes back to the point about different software and hardware being able to speak to each other, is major. Sorry, and I can see some comments in the chat which I can't acknowledge now, but I will look back. And then trust and explainability, so recognize that these systems can be a bit of a black box, and which makes them quite difficult to accept in the energy sector, which is quite renowned for being slow to adopt technology just because of how high risk it is. And a skills gap. So you're all doing your part by being here and hopefully picking up new skills and information, but the energy sector is sorely missing experts with high data and digital expertise. I'll try and speed up where I'm pushing time. The UK regulatory...
Sorry to interrupt you. So I'm just trying to be conscious of time. I'll probably just give you like 1 minute to quickly round up, if that's okay.
Okay, sure.
Thank you.
So broadly, I mean, the UK regulatory landscape is quite pro-innovation, with a few principles around like safety, transparency, fairness, accountability, and contestability, which obviously you can do your own research if you're interested in. And Ofgem has published some guidance, which I have a screenshot here, but do feel free to check it out. And investment is increasing through the Strategic Innovation Fund as well, which I won't dwell on because of time, but wanted to acknowledge it. Um, there are various ways that AI can be involved, which vary depending. Basically, not every single problem deserves an AI solution, and there are various levels of AI involvement within that. So I've got this screenshot from a person called Tay Bannerman, so do feel free to check it out if you're thinking about explainability and the role of AI in the sector. And I guess the last slide is just if you were to personally want to leverage generative AI today, going back to the point I mentioned, the main problem I see people struggle with is like how to use it, what to use it for. So, and I think the best use cases for generative AI, so ChatGPT, Claude, Gemini, these sorts of things, is around brainstorming, structuring, summarizing, copy editing. The main thing I stress is prompting. This is where most people get things wrong, is being very vague with their prompts. So I very much stress being very clear in your goals and almost treating it like an intern, giving it the information that it needs to make a correct output. Ask for gaps, like feel free to dig into things further, like ask it, what did I miss? How could this be improved for X condition? Who could this tool or output harm? And then just bear in mind guardrails, like not sharing confidential data and things like that, and using enterprise software where possible. And that's pretty much it. Do feel free to, if there's any questions, I'm happy to take or connect to me on
Thank you
LinkedIn. Happy
so
to
much.
respond.
Thank you so much. Honestly, I just want you to keep talking, if not for the time constraints. That's really amazing. Very insightful presentation. And I like the way you've connected the dots. You've talked about generative AI. You kind of connect the forecasting with the flexibility, citing and the layout optimization. You know, this is the kind of strategic insights that we need our audience to kind of understand, and not just where the AI is heading, but how the energy industry is also evolving to support it. I can already see the chat is buzzing with engagement, and I can see questions coming in. Kojo, are you ready to address some of these excellent questions within the next 10 minutes? But also, I want to remind us all that we might not be able to answer all the questions because of time live now. Like I said in the beginning, subsequently, the some of these answers to the questions will come with the post event email in your email that you use to register. Okay, so I'm going to leave you to answer the question. The first question goes, and so is there one AI solution or platform that can tackle multiple use cases in forecasting, flexibility, optimization, demand response, etc.? Yeah.
Yeah, there's definitely not one that I know of that's doing this and or doing it well. I think there are some attempts to make like foundational AI models which can do multiple different things and can in some ways serve as a base model that further AI applications can be trained on and specialized in. There is a foundational model called Grid FM, which some researchers are currently kind of working around to make that the standard foundational model for the sector. But I don't think there's one solution. I don't think I would also be the best way forward, just because the energy sector itself is so complex and so challenging, and building an AI model that can do all of these different things would be an incredibly difficult challenge to get right. I don't know. I think you require a lot of data from a lot of different areas. Number one, um, the compute cost in maybe training a model that can do all those things would be such a challenge. And then trying to make it useful in all these different things would be very problematic and difficult. I think generally I kind of lean towards smaller AI models as well, like smaller specialized. I'd rather you have a dedicated model which is amazing at doing this specific thing than one which is okay at doing many different things. Um, And I guess the only sort of entity I can see using a general model would be, like a system operator at the national level or a system operator at a regional level. And usually those teams are quite specialized in themselves anyways, that they would just use specific tools for specific jobs. So the short answer to that question is no. And I don't necessarily think it will happen, but we might see more foundational models which can then be, specialized for different things on a higher level of the stack.
Okay, thank you so much, Kojo. So I'll just move on to the next. I'll skip this one and come back to it much later. So most of the discussion here has been centered on renewables, which are undoubtedly the future of energy industry. However, combustion systems powered by hydrocarbons are likely to remain in use for several more years. In your view, how can AI be leveraged to improve the thermal efficiency of these systems and reduce their carbon emissions?
It's a good question. At the catapult, we don't, or at least I say I don't do a ton of work around hydrocarbons. But I do think in the short to medium term, you are still going to rely on hydrocarbons, particularly for making up that shortfall of energy. Like I said, we're not ready to move towards a completely renewable, world. We haven't figured out how to manage flexibility. For example, I think increasing AI and flexibility is where we can then begin to decrease our reliance on hydrocarbons. But specifically to this point, um, I think the answers to me seems quite simple in that you still would use AI for like better designing of materials, better designing of uh processes. AI for manufacturing, and manufacturing is already manufacturing and the built environment and these sorts of heavy industries, which are already quite heavy and polluting. We're seeing AI being used for better design, better planning, for better modeling of these environments. Um, so whilst I'm not aware of specifically how AI can be used to make them more efficient outside of just testing and using AI almost like a co-pilot for further research, which is a pretty much an answer I'd give to challenges in the energy sector is that AI is being used in the sector to support research and better designing of systems. So I haven't got a great answer for that question. It's not an area I work in a ton of, but happy to look into it more.
Yeah, thank you very much. And so the third question, one of the biggest issues at the moment is strategic planning. And when it comes to distribution and transmission network, where do you see AI play this biggest role in the near term, especially with so many bodies responsible to address this issue, like the NETSO, the DNs, and the DNOs and TOs?
Yeah. Where do I see AI playing the biggest role in the short and near term? I guess it's still flexibility. Um, because it's rather than planning for new distribution, new transmission, which like I mentioned is very expensive and intensive, and um, the system operators are hesitant to do things like dynamic line rating, for example, which is was like rating the efficiency of a line, like rating the efficiency of electricity that can flow through a line in regarding the wider weather. So you're basically ensuring that the line will not become overheated. If you know what the rating of that line is, what its capacity is, and you can send as much electricity through there as required, which means you no longer need to um, at the moment reduce the capacity for that line to very low levels so you don't overheat it and so you can avoid things like brownouts and blackouts. If you can rate that line more accurately, you can send electricity through there more accurately. And that ties into better weather forecasting because so you know if it's going to be particularly hot, particularly cold, things like that. It's how you can avoid developments like building infrastructure and planning infrastructure. So I see AI playing the biggest role there for in areas like dynamic line rating, in areas like forecasting, in areas like flexibility, where you don't need to make new systems and you can just do more with what you have. Yeah.
Yeah, thank you. I hope it answers the next question. So, the next question quickly, any reliability rates or percent with use of AI in specific energy areas you've worked on, plus how is deep analysis trying to improve these figures?
I'm not sure I fully understand the question.
Um, so it says any reliability rate or percent with the use of AI in specific energy areas. Like,
I think it's
I guess if speaking to the reliability of AI in
yeah,
the various areas, definitely not a number I can think of offhand. I think this is still very much nascent. The focus on AI is very much nascent. So we're increasingly seeing research in different areas. I shared the Seagrave report, which spoke about AI in the control rooms. That's probably a really good resource for looking at which system operators, because it was an international report, which system operators across the globe are using AI in the control room. It speaks about the challenges that they're facing. It also speaks about the applications of AI they think will be most impactful, and has a percentage for those different areas. So most of the system operators, for example, are using AI for forecasting, but most of them also think that AI for congestion management will be the most impactful use case, but it's also not being used to. It's also, I think, the lowest use case currently. So there's obviously a big disconnect between recognizing that AI could be very helpful for managing congestion on the grid, but also not adopting it because of inherent challenges around, explainability. It's a very high risk environment. So that it innately serves as a barrier. So yeah, no number I can speak of head, but if you're interested in at least AI in the control room, I'd highly recommend the Seeker report I shared.
all right, thank you. And there's another question. What are the current and upcoming prospective AI related roles in the energy industry?
Um, I think I would place a lot of emphasis on data science, which is which has been around for a very long time. But I think the sector in itself needs more data scientists, more AI scientists. Um, NISO, for example, is building out a data science team. So I think just broadly any expertise with data science, with languages like Python, which I'm not very proficient in. My background is much more socio-technical, but even I'm finding that I need to increase my technical skills and coding ability. So I think I would stress broadly data science skills as being incredibly useful.
Okay. Yeah. So the the next question will probably just be answered in the next section, if you don't mind. Bear in mind, like we said, all questions will be answered, but not necessarily live. If we're not able to now, then the feedback question. So thank you very much. We really enjoyed your session, Kojo, and that's really absolutely fantastic. And I'll let you hand over to the baton to Richard.
Yeah, brilliant. Thanks for your time. Yeah, thanks everyone, and Richard, I'll hand over to you.
Yeah, thanks. I will share my screen now. Please let me know if you are able to see this.
yeah.
Yes, we can.
Great. Great, thank you. So, yeah, my name is Richard. I work for a company called Miros, and I will talk about challenges and opportunities of AI in energy industry. In my session, first half, a bit of intro about myself, a few use cases I've seen to set scene to help talking about opportunities and skill gaps. A bit of preview that opportunities and skill gaps, in fact, pretty much always come hand in hand. And then the second half of my presentation, I'll talk a bit about future with AI, a few thoughts on how it may impact our lives, our job market, and a few thoughts on what may help us adapt better. So for me, I started my career working across a few consultancy companies doing wind farm resource and performance analysis, a little bit like example number 3 in Kojo's presentation. And there I saw some machine learning algorithms being developed and more quickly than non-AI approaches and more accurately or precise or powerful at times. but my emphasis on at times. Sometimes it's better, sometimes it's not as good, and I'll talk a bit more about this later. But as I see the power of machine learning, I got more excited about AI. I studied more, and then I thought, hey, there are a lot of advanced techniques outside where I was working at the time. So I looked around. I got my last job as a cloud platform engineer at Microsoft. I got to support major energy and finance companies. And I got to see AI got algorithms of all sorts being used for estimating energy prices to help senior management strategy and investment decisions. Energy yield, like my previous example, customer transactions in huge volumes, and with that comes fraud prevention. Then I moved to my current role at Miros. We provide real-time ocean insights, supporting energy industries offshore operation. I put a little QR code. You can see some of the open public view examples. At the current role, I see a blend of use case of previous two together, and I'll talk a little bit more. We use machine learning to optimize weather condition forecast and prediction. One example I'll talk a bit now, and it will be used again later, hence my example, is we do wave and vessel motion prediction. And how do we achieve this looking ahead prediction of what waves and vessel motion will happen? Is that we take the radar that scans around the boat, and we can then see large waves coming, travel towards the boat you're on. And with that, we derive the wave height, traveling velocity, and direction. With that, we are able to give the captain, the operators, and even their colleagues on shore of what kind of large freak waves will impact their vessel in the next few minutes. With that and the vessel's onboard motion reference unit, with machine learning and correlation, we're able to also give all 6 degrees freedom of vessel motion prediction. So with that, it's a few different machine learning, artificial intelligence use cases here. So then, I want to come back with each point. The first point, I could see a lot of energy production sites jobs follow this kind of resource analysis tasks. Now let's look a bit about the opportunities and skill gaps in here. I would say in the first example, we're seeing a lot of technical experts of different backgrounds, like wind analysts, geophysics, for example, and then they upskill to learn how to be good at creating machine learning algorithms. So here comes opportunities and skill gaps because whichever team you're sitting in, if you're dealing with data, chances are by learning to become better at creating machine learning algorithms, you will become very popular. Also, earlier I mentioned I also saw use cases that AI don't always outperform the non-AI approaches in this area. And that also highlights the skill gaps and the value of if you are able to be good at creating machine learning algorithms, then you will have a bright future. Then come to the second point. It is all sorts of different artificial intelligence algorithms being used, but a lot of time it is not about dealing with the most intricate, complex rocket science calculations. However, it is how to run the same task, how to achieve the same task as lean, fast, reliable, efficient as possible. So then it becomes how to make your code run quicker and lighter, but also the right cloud platform underneath. So in the first example, we saw a lot of experts running intricate codes on PC or local server. On the second example, it is mostly on cloud, and then it is a lot about data platform architecture and design. In the first example, I would say 3/4 of the colleagues were subject matter experts from their own background and started learning machine learning. And the second example, probably 3/4 are the computer science graduates, and whenever IT industry is high on demand, it is regular that they hire other people to come in and train up on the computer science platform engineering knowledge. Now to my last point, we are a supplier, and then it becomes quite similar to taking what are the best, most robust, sellable examples of the first point, and then you need to commercialize it. So when you start to commercialize it, you start thinking about licensing, version upgrades, remote troubleshooting, and user interface. So with that together, you gotta start thinking about how to make good platforms underneath. So then it becomes very much a handshake, a fusion of also with the second point. So in the third example, we start to see perhaps a half-half division of half of the tech team being computer scientists, the other half being subject matter experts. In my current company, those would be radar experts and oceanographers. So at this point, I want to also quickly mention for anyone thinking of making an impact in the energy industry, I highly encourage also look at the likes of consultancy companies who would be like the first point, and the suppliers to the energy industry, like the second and third point. In fact, to the third point, energy industry absolutely go hand in hand with maritime. In case you didn't know, all of your offshore wind farms, offshore oil platforms, or any energy transmission cables, pipes, lines, all that construction have to be done with the offshore operators, and the maintenance have to be done with offshore operators. So when we are able to support the offshore operation to become more resilient, more efficient, and reduce the carbon emission, then all have a huge impact to the energy industry. Last but not least, before we leave this first half of the presentation, on the skill gap side, I want to quickly mention that regardless the jobs and markets, a huge part of thrive is in fact how to communicate technical understanding to human of all different backgrounds. And I'm seeing that in all the different teams I've worked at. I'm highlighting this because this is always going to be an inevitable part in parallel to whatever you want to pursue. And a lot of time, this is going under prioritized in more technical departments when we get more focused on learning technology instead. And we will come back to more about the value of this again later. So comes to the second part of my presentation is about our future with AI. I think it's safe to say that we've seen all these things, ideas, and mindsets in the past. Some are positive, some are negative. So yeah, we'll talk through them and a bit about how the future new technology may impact our living situation, job market, and what may help us adapt better. So I get hear this conversation all the time. Yesterday lunch with my friend was the most recent time. But then I frequently also think, with a lot of discussion on AI replacing human and the fear of it, but it is very important we start to think, is that what they set out to do? Because in fact, each AI product is a tool created to be good at certain tasks. And also my next point will come hand in hand to any subject matter experts want to upskill and create machine learning algorithms. It provides you a very good starting block. So if that applies to yourself, then a good point to start is, all right, what are computers good at? What are AI good at? Because if we decide to create features and tools that fundamentally are not so good to be done by computers, then you might have a bad time. So I want to bring you to some examples outside energy industry. We can now all easily download chess games that powered by AI. I download it in a matter of minutes on my phone, and they can outplay most human experts. When chess is regarded as some of the smartest people being good at it. On the other hand, the AI algorithms may not be anywhere close to do a lot of tasks in our daily life. So for example, to create a robot powered by AI to go into a kitchen it had never seen before and say, please empty the dishwasher, the robot cannot do that. And to create a robot powered by AI to do the job as good as a mediocre plumber, the AI is nowhere near to execute that. So we start to identify, oh, okay, some tasks may be very hard for human, but computer can be good at. Some tasks may be ordinary for us to carry out, but computers are terrible at. So a starting block can be tasks that are repetitive with defined rules that are usually very good to be handled by computers. And in fact, this kind of tasks, very repetitive, are usually not so fulfilling for most people to do. So that's great if we can take that away. So the above talks about, okay, what features are good for AI to be created? And then we start to fill some opportunities and skill gaps. But I also encourage you to think, okay, then what are the opposites? Because when you start thinking that, then you start to realize what tasks are unlikely to be replaced. And then it's good that we know what tasks we can do well to stay relevant in the job market in the future. So with the last slide in mind, we have identified many opportunities suitable to develop AI-powered products. I call these developers, probably pretty intuitive to understand why. And then we started thinking, what are the areas not suitable? And I encourage you to think that not just towards AI, but towards all the technologies. Then you will find tasks that still will be relying on human heavily in the future. So once we identify those, then I start to encourage you to think, all right, to complete those tasks, are we able to take certain technology tools and then with human decision, and then we can do well with that. So then to be efficient artificial intelligence tool users and orchestrators, then you will be popular in the job market. So I'll give you a few examples on this. One parallel example of decades back. So a few years ago, I saw this movie called Hidden Figures. Perhaps some of the audience have seen it. It's based on a story of three female African-American mathematicians worked at NASA during space race. And their whole team's job was calculator. They were brilliant mathematicians, and then you had the engineers, chief engineers to say, all right, here's my rocket, here's the dimension, the way, here's the thrust and the fuel, and this is the weather condition. So please tell me where the rocket will get to at what time, and the calculators go and calculate. In fact, I think they are better mathematicians than most of the engineers in the team, so they are incredibly skillful and valuable. However, to this day, we don't really see teams of calculators around. On the other hand, we have junior analysts, engineers able to do computer programming and to handle a huge volume of calculation compared to the space race era. So then in parallel as the technology developed to the future, we will need new kind of orchestrators and users of new tools to be most productive. And to me, to think ahead of that, then we will always be relevant and will be impactful. And I also want to take a quick comparison of users and developers and AI tools. So come back to the Mirror's wave and vessel motion prediction example. We are able to use computers and artificial algorithm to help us accurately predict the wave and vessel motion going to happen at a certain boat a few minutes ahead. And in fact, the sharpest of mathematicians probably cannot calculate that fast. So in a sense, this tool came along, did not take away anyone's job. However, it empowers us to make even better decisions to be more productive. On the other hand, once that wave and vessel motion prediction is available, artificial intelligence algorithms It's nowhere close to do the rest of decision making of offshore operation because that is incredibly complex. So we still rely on the vessel captain and operators to make that final decision to execute and to complete their projects. So there comes the value of being good users and orchestrators with the right tools to do more than before. Last point on this, I want to talk about an idea called educator. So earlier I mentioned about artificial intelligence algorithms being good at playing chess. And when they first outplayed the best of human grandmasters, and they made some crazy moves that human wouldn't do if they were good at chess. And for a normal guy like me, I don't play chess. I didn't know why the algorithms do that or why it was good. However, other chess experts went and studied it, and then they were able to explain to others why those moves were great. So AI itself is nowhere near explaining all the new approaches to human public effectively because they make decisions based on correlation score. It's a simple percentage impacted by training data, method, and penalty functions. So there will be the need of subject matter experts to come and study AI with the knowledge of how artificial intelligence algorithms usually work. And then they are able to debug and say, okay, this is a great new idea, or this is unlikely to be useful. And that was because maybe the training data was actually biased and it was hard to get a very clean training data to start with. So let's not waste our time diving into the wrong approach. I personally think that more and more roles, jobs, will take on tasks of being good educators. And if you are knowledgeable of how AI works, then you will be valuable being able to educate others. On the other hand, my personal take is perhaps in the short term, we won't find a lot of jobs that the sole purpose is to be educators. So having that in mind also help us navigate through the next part of the career. Now we're coming into the final bit of my presentation. I want to bring up this idea called CI/CD. It is a framework, a pipeline that most of the software engineers do follow these days. So I highly encourage you to look it up. It's not rocket science, it's pretty straightforward. However, even if you are not thinking of becoming a software developer or writing AI algorithms, I am taking this as an example of how we can take the principle and help us develop of our career. And to implement CI/CD, it comes with continuous learning, which in fact, most people don't like. Most people like to finish the higher education, go into work and keep applying what you know instead of keep reviewing and taking the feedback. That's the hard part. So to make that a bit easier, I say to have the right curiosity and interest to technology, to the movement of industry to our society will help driving this naturally. And if that is not enough to convince you to adapt, then Mr. Albert Einstein said the measure of intelligence is the ability to change. So perhaps that also go hand in hand. The next part is I want to say is to be mindful of all the good and bad, the risk, rewards, concerns, interests towards not just artificial intelligence, but new technologies and policies in general. We don't have to agree with every aspect from everyone about what they think of new technology, but it is valuable to be aware of the different ideas and the reasons behind them. Because at some point, sooner than later, we would need to interact with these people of different mindsets. They may be our colleagues, customers, family, friends, and to work with them well, it really helps that we are aware of where they're coming from. Lastly, if you haven't noticed, I'm saying curious in every point, and the last is on how to improve. So why do I say this again? I was inspired once listening to this podcast by Lex Friedman and a guest guest presenter, an AI researcher, went on the podcast, and Lex asked him if he thinks that AI will replace our jobs. And his answer was along the lines of AI will not replace human until they know how to dream. Dream of how to do tasks better to improve our lives. And to me, that is a fundamental part of human mind, and that's not fundamental to computers. So keep that in mind, and I think we will do just fine. So thanks very much. That's the end of my session, and hope that is useful. Thank you.
Thank you very much, Richard. That was really insightful. You connecting skill gaps and opportunities to real life, relatable examples from chess to movies to podcasts. That's amazing. So thank you so much. I think we'll just use the next few minutes to answer a few questions that have come up in the chat. So I guess the first question I see is given the role of growing given the growing role of AI in energy systems, any idea how the UK is addressing the digital skills gap to ensure enough experts can deploy and manage these technologies?
Yeah, perhaps not just UK on its own. I know there are various UK training bodies and data science organization available to help providing the right training. But besides that, looking across the globe, there are a lot of learning materials, a lot of time for free online, and that can come from any countries. I think again to take that initiative myself when I moved from the wind resource analysis consultancies to Microsoft, I listened to a lot of podcasts. And then when I moved from Microsoft to my current role, I also watched a lot of YouTube videos about this specific use case to my new role. So I would say besides UK itself, there's a lot of online resources, but yeah, I don't think we're short of them. I think it does take time to go through them. And another hard part is to find the materials most relevant to you, because perhaps by the time you go through the first two, three sources, you realize most of them are covering the same points. And then at that point, it's easy for human to stop focusing our time on it. But yeah, learning and technology improvement is a continuous process. So I hope that helps.
Yeah, that helps. To the next question, as we increasingly rely on machine learning to support operational efficiency in offshore renewables, how do we overcome the challenge of limited data sharing between companies, particularly when commercial sensitivities or competitive interests prevent the kind of collaboration needed for AI models to learn effectively? A long one, but I hope you got that.
Absolutely, yeah. I'm smiling because that is a great and popular question. I had two things in mind. The first, more funny perhaps, is if I had the absolute answer, I would be very happy and probably solve a lot of the world's problem. The policy is always going to be there, and I totally understand there is the need to keep your company sensitive information. In fact, when I visited some of the wind farms, the only relevant colleagues at certain department could go into the control room side of the O&M base. The other, for example, stakeholder managers, they were not even allowed to go into the more data heavy side of their own company. So it is very tricky. The offshore wind data is being regarded as national data, in fact, because it's met ocean and energy production. On the other hand, it comes challenges, comes with opportunities, and wind industry is not the only one hoping to be better at machine learning without huge amount of data. So if we look online, not focusing on wind energy, but look at how to improve machine learning with lower volume data, then there are a lot of research materials in place to help us do better. Of course, if we only focus on the technology advancement, we hope those policies were not in place. The reality there is, and then the smarter minds who are able to thrive with lower amount of data, you will have a good career ahead.
Awesome. I think there was a follow-up. Maybe you can just touch on what mechanisms or incentives in the UK could help unlock this data while maintaining trust and protecting intellectual property.
Absolutely, yeah. I would say when I think about protecting intellectual property, that is always going to be a never-ending job for us. So having that in mind, it can be frustrating. We just want to get ahead and create innovation that helps the society to move forward. But that's the reality. Every company needs to protect its intellectual property and the country also. So that is always going to be the case. Then we just need to be mindful and know that we will always have to spend time working with it. On the other hand, the mechanism and the incentives, there are a lot from Innovate UK to catapult related. So not just energy catapult, also offshore renewable energy, ORE catapult, and many other funding programs available. So there are them in place. I do also share the struggle that when it comes to looking up these opportunities, sometimes it's hard to have one source telling us every new opportunities coming up. So again, it does take time to keep up with it.
Okay, thank you for that. So there was one question that was was up in the chat. Kojo addressed it, but I also want to hear your thoughts as well. With the growth of AI and digitalization, comes the risk of cybersecurity. How do we ensure our future energy systems are robust enough?
Yeah, I can give you my best insights. I myself am not through and through cybersecurity experts compared to especially a lot of my ex-colleagues at Microsoft. But once I heard a cybersecurity expert on the Sam Lex Friedman podcast being asked a similar question of what are your views of cybersecurity facing the new sharper attacks with the help of artificial intelligence and alike? And this expert actually laughed and said, we always joke with our team that cybersecurity is job security, which meant it never ends. Probably a little bit like lawyers. There will always be a need for it. And it just needs to keep evolving. And there will always be cybersecurity experts dealing with that. And then it comes to that cross-team communication skill of, okay, I myself come from energy source analysis or operation and maintenance background, and how do I discuss well and implement new strategies with cybersecurity? It is an incredible, huge part of the industry, and it's also interesting from my take that having worked at Microsoft, looking at financial companies and then looking at how each offshore site is done. In fact, I have seen the same energy company and their financial team handle cybersecurity protocol being so different to their offshore platform team. And at first, I was very surprised, but now I realize that's the reality. So it is a continuous process, and that also kind of means from my side, I cannot give you a one-liner of how to fix it now and ever.
Okay, thank you very much. Ooh, will it be possible that in just 1 minute we can address this question that has come in operational efficiency, especially for offshore wind? How do we use AI, ML to improve safety and risk assessment during construction and operations?
Yeah, that's I really like the thinking, and maybe analytical side of my brain, it would say that it's going to be very, very hard. And I give you a bit more background, is I myself also work with new technology being applied towards construction and operation phases of risk assessment. And they really favor tried and tested methods. So for example, the consent team, they are looking at every single component and new sensor technology, operation strategies, and say, what are the risks, how likely it's to go wrong. So then it creates a vast amount of variables. So to have a broad brush over this with AI and ML itself, perhaps would be hard, but then like my earlier example of, all right, let's then dive a bit deeper. Which components can we break down that's more repetitive that we can use AI to help correlate and calculate? Then I think we will be moving forward a few steps if we dive down and think, all right, then which component can be relevant to be handled by that, and then take the output of the calculation, and at the end there will still be that human judgment element to make the final call.
Okay, thank you very much. We're excited and inspired by your presentation today. Yeah, thanks so much. I think we'll just move to the next session. I'll just share my screen in that regard.
Yeah.
Okay, over to you, Janila.
Okay. Thank you very much, everyone. Thank you so much, Richard. Very inspiring and very exciting. Honestly, my mind is really blowing right now with all the examples and the fact that no one is going to take my, I mean, AI is not going to take my job away. Right, so here comes my favorite part of this event. We'll be having an interactive breakout session, and we'll get to engage directly with other people, network, and share your own perspective. So we'll be dividing you into smaller groups for thought-provoking activities, which will really get you thinking about AI in energy. So you'll have 7 minutes to plan and discuss. So I'll encourage everyone to participate actively because you'll be learning a lot. So remember the insights you've gained from the speakers, and obviously even the ones you gain from each other in this activity will be as valuable as the ones you've learned from the speakers as well. So once you're done with the brainstorming, you can just decide the spokesperson who will present the ideas and thoughts within 1 minute. So let's make this engaging and authentic, because your diverse perspective are what will make this discussion really valuable. So there is no right or wrong answer here. So the question goes, AI can help, but it can also harm. What is one area of the UK energy transition you think cannot depend heavily on AI, and why? So the clue here is just to think critically, consider areas where human judgment is very important, ethical consideration, and safety concerns.
Okay, I'll be opening the rooms now.
So one other thing, so Christabel and I will be rotating between rooms to check in, and we'll just reconvene you back to the common room afterwards.
Hello, yeah, can you add me to a breakout room?
I've been into three, so it seems everything is going on well there. So I'm just yeah, I'll just go back to it now.
Yeah, yeah, if you can add me to a breakout room so I
Oh,
can
oh,
join the
okay.
conversation as well.
Okay. Oh, let me see. Will I be able to do that? Let me just see.
But it's fine if that's not possible.
Oh, okay. Yeah, I think I should be able to. Yeah, I will be able to add you to it.
Okay.
Um, Assign to maybe just take you to Chisom is in room 2. I'll just take you to room 3. Join. Assign you to. Okay.
Awesome. The breakout room should be closing about now.
There's already notification to each of those rooms that they'll be coming in maybe less than 1 minute from now.
Okay, that makes sense. Is there a way we can automatically close the room such that everyone comes back here?
I think, yeah, of course, there is a way. I can do it from my hand. Yeah. Yeah. So I think it's already saying 56 seconds.
Seconds. Okay, that makes sense.
Yeah. Welcome back, everyone, since we are all having everyone here back. And I've actually had the opportunity to visit some of those rooms, and I can see the energy in the room. Should I say virtual energy? Um, which I noticed it's really shifted the discussion from low to high. And I'm sure that you've all had some fascinating and quite honest conversation. So, which team would like to kick off first? Feel free to. Okay, so should I say from section 1? All right, someone is already saying. So it says Cornelius, would you like to take up the mic now? What breakout room is that? Can you hear me? Okay. Cornelius, can you hear me? It looks like you're off. Yeah, okay. No. Okay. Okay, let's start from breakout room 1. Let someone, the spokesperson from breakout room 1, speak. Feel free to turn on your camera, please, as you speak. Okay, should we then move on to breakout room 2?
I think Chibuzo in group 1.
Good afternoon, everyone.
Okay, yeah, that's it.
Good afternoon.
Good afternoon, everyone.
Good afternoon, thank you.
So I'm going to just say a few points. Yes, AI is good and it can help us solve a lot of problems. I wouldn't say it can cause harm. I don't know. I wouldn't use that word, but there are things that I believe AI can do for us. There are things that I believe, there are points I feel like AI can do for us. So I'm going to say one, when it comes to community engagement, when it comes to human interaction, I feel that AI can't do that for us because, for example, in my field as an architect, in terms of designs, you have to you have to get your client brief. You need to listen to your client to know what your client wants. Even if you want to make use of an AI software to design whatever he wants, you need to kind of have that human interaction with your client before you could go ahead with AI. So that comes before AI. So AI can't entirely do that for you. Then I'm sure it's the same for every other field. I don't know, every other practical or technical field, but in architecture and probably engineering and some other fields, I think it's like that. Then coming to policy and regulation.
I'm sorry, I would like to cut you, interrupt you there. It's just because I'm being aware of time. Thank you very much.
Oh, is that okay?
You've
Oh,
knocked
all
it.
right.
Yeah, you've really said very, very reasonable thing like interaction with clients, stakeholder engagement. AI is not going to be able to do that for us. Thank you so much. That's amazing, brilliant. And the next breakout room can come up to present, please. And I'm so sorry, I was actually meant to tell you that I've already said it before, but I'm just supposed to remind you that The presentation is just going to be 1 minute exactly. So when it's 10 seconds remaining, I'll remind you so I won't have to interrupt you again. Yeah, thank you. So please let the next room present.
Okay, thank you. I think what we said was just around what the last person said. So like I just said, AI is good for prediction, forecasting, like transmission lines. This is where you put it and all that. But there needs to be human-led, like safety, the impact to the communities and all that. And I think the second thing was like for new technologies that have manual faults, like there are no like historical data. So when they predict, like the algorithm is not really accurate. So it was just based on those two discussions we had. So like human-led factors, safety needs to be known, even when AI predicts that we should erect a tower here and all that, but the community impact is really important. Yeah.
Thank you so much, Chisholm. And that's amazing. And let's have the last breakout room to come and do their presentation, please.
Hi, I'm not okay, we're probably the last room. That's room 3.
Yeah.
Okay, hi, my name is Moshokwe, and I'm just speaking on behalf of Group 3. And we spoke about similar things as well, but we touched on 2 topics which were relating to customer satisfaction or customer management, where sometimes you reach out to your energy companies now on certain questions. I know we have the FAQs and surveys and things like that, but sometimes you still need human interaction to answer some, maybe more difficult or more complex questions. And the second thing was related to, can you hear me okay?
Yes, of course, of course.
Okay. The second thing was related to operational safety and risk assessment, which is the question I asked Richard as well. Sometimes, especially as consenting persons, we have to go out on site, you have to assess things because these are really big infrastructure projects and you don't want anything to go wrong. And in split seconds, if things go wrong, you have to make split decisions, which are things that at the moment we don't necessarily see AI doing for us. So those are the 2 things we talked about. Thank you.
All right, thank you very much. So honestly, I really appreciate everything that you guys have said because I really appreciate the diversity of your viewpoints, which is exactly what we are hoping for. And certainly have learned so much from the response from each team, stakeholder engagement, safety, human-led, and customer management from the last room. Thank you very much. And now let's move on to the next activity, which will allow us to do some quick harvesting of our thinking. It doesn't have to be perfect. We just want to hear your genuine perspective from this. Like I said before, there is no right or wrong answer here. So it doesn't matter whether you're crystal clear on your path or you're still exploring your options. Your perspective will add value. So the question goes, what does a career in energy and AI look for you? Is it a merge in career, a career change, or does it mark the beginning for you? So I'll just be we need 3 or 4 people depending on the time now to just talk about it for 45 seconds to present your thoughts. Does anyone want to go with this mic now, please? Anyone
I
come
think
onto the
that's
mic?
fine. We'll be able to say 2 people max.
Okay. Yeah. Okay. 2 people. Yeah. The first person, anyone? Or should we just randomly select someone?
Yeah.
Okay. Okay.
I'll go with say Chimka.
Chimka. Okay. Chimka, let's have you on board. Please turn off your mic. Feel free to turn on your camera. Let's see you.
Chimka. Hi, good afternoon.
Good afternoon. Thank you.
Yeah, so AI has been an interesting part for me recently because of my MSc program and my dissertation in that I finally just submitted. I had to work on using application of AI for prescriptive maintenance recently, and I have not been. It was something that was new to me. I had to understand how it operates and its function, and able. So And in applying it to energy industry, I'm thinking about using it for prescriptive maintenance.
Okay.
Yeah, mostly because at the end of the day, recently, oh, we end at predictive maintenance. So to take it further, it's be an eye opener to so we can use AI for prescriptive maintenance, just to
Thank
tell
you so
people
much.
what to do.
Yeah, thank you so much, Jim Carr. Really appreciate that. Really appreciate your thoughts, and those were quite brilliant. Any other person wants to go? Just one more person. Anyone wants to volunteer? Or let me just pick up. I can see John Uriok. Please turn on your
Yeah,
camera.
I'm
Yeah.
sorry, I'm not in the best position to turn on my camera, but yeah, I can speak to the microphone
Okay, carry on.
if that's okay.
That's
Yeah,
fine.
so yeah, I mean, currently I work in an energy startup that, tries to provide digital solutions for for the renewable energy industry, right? And more of operations and maintenance, that is remote monitoring of solar installations across Africa, right? So I see a lot of interplay between energy and data, and yeah, I get to see the applications daily in my role. Right. So for me, we've gotten a couple of requests from, even existing customers around analytics, like they want to see insights into their energy data, right? For instance, there are questions on curtailment. How do we predict exactly when curtailment is happening on a particular solar asset? And there's also the topic on fault detection, right?
Um,
So
s-
okay,
Sorry.
time up, right?
Yeah, time up, sorry.
All right, yeah, so
Yeah,
yeah.
thank you so much. We've listened to different perspective, and that actually sparked ideas for me personally, which I believe would also be applicable to every one of us here. And I mean, about things that you actually not considered before. So I'll be handing over to um Christabel. But before then, Brian Ima will be having event snapshots. So please don't forget to turn on your camera to have this. Thank you.
Okay, thank you very much. So sorry that we're strict on time. We're trying to keep to, the time that we gave everyone. But we're so thankful for sticking with us through this event, and we just want to, get your feedback. So again, if we can just all go on Slido and just quickly run through, feedback polls, that would be great. So first question, on a scale of 1 to 10, how positive do you feel about the future of AI in energy? Uh, let- it'd be great to have a few more coming through. Okay. Okay. So that seems to bring us to a result of around 7.9. And that's pretty good about how positively we feel about the future of AI. Right, I'll just move on to the next. What have you learned at this webinar that you did not know before? Just we're curious to see if there's something new you've learned. Oops, sorry. Uh, you don't need to type, too much, or you could just say, okay. Okay, hope to get, a few more in there. Hopefully we can get, say, one or two more. Okay. All right. So a lot of it it's surrounding opportunities, the diverse uses of AI and applications, opportunities and limitations, which were all covered in this webinar. Thank you so much for that. And then I would just have to move on to our final question. Just doing that now. Nice. And finally, overall, where the session's useful and relevant to you in your job role, in your area of interest, etc. Okay, we're glad to know that a lot of people find it useful or somewhat useful. Okay, amazing. Thank you so much for your thoughts on this and for your feedback. We just have, some further feedback. You can do this in your own time, but say we just want to, have some further questions on how you found the survey. And so maybe within the next 10 seconds, if you could just, scan the code uh, and then get to the feedback form and just let us know your thoughts on that as well. We will truly appreciate it. Yeah, I'll just give like 5 more seconds for this. Okay. Yeah. So just before we close, I'd like to invite Kojo and Richard, if you're still with us, say within 30 seconds, if you could just highlight key takeaways that our participants will be leaving with from your presentation. So I'm going to start with Kojo.
I guess I would say definitely the AI applications, as was mentioned, that people have taken away that AI is very broad as a field and that there are many ways you can get involved in the sector. And I think also the key challenge is being data availability. So do encourage your own organizations to share data, do talk with other people about sharing data and find infrastructure to do so, and generally increase your AI skills and in all the various ways you can do so.
Okay, sure. Thank you so much. Richard?
Yeah, probably like my last slide, I would say stay curious towards the very broad aspects of AI and technology overall.
Awesome. Thank you so much. So yeah, this really brings us to the end of today's session. Thank you so much for staying with us. Connect with us, both Energize Black and the EIYPN West Midlands branch. We're on LinkedIn. We're also on social media. And you can always, find us on the internet website. You can also connect with us via email or join us you can scan the QR code to join Energize Black or go onto the EI website to join EI as well. And then don't forget about the training course that EI Jalilat mentioned, that there's the artificial intelligence AI in the energy sector that you could take as a resource or material to, further your knowledge on AI. Yeah, at this point, I guess it's a big thank you to everyone. Thank you so much, Jalilat. uh, yeah, I think you are on mute.
Oh, sorry. What an incredible afternoon this has been. And I want to take this moment to properly thank everyone who has made this event success. Kojo and Richard, thank you. To our amazing audience, thank you so much for your engagement and your thoughtful questions, sharing your personal career visions, and then I also want to thank our incredible partnership with Energize Black UK for their collaborations and share commitments to professional development. Thank you so much, Energy Institute West Midland Young Professional Network, for creating this platform like this.
Yeah. Before we go, we just have one big ask. We just want to get a picture of everyone. So if you can, just turn on your video. I'm going to just take a screenshot. Let's get a picture with our speakers. And yeah, this is going on social media. So I'm encouraging everyone who can, please, let's have your videos on. I'm gonna be doing that. I'm still waiting for just a few more, if you can. Uh, okay, so I guess in 3, 2, 1, if we're ready, give us your best smile. All right, thank you. No, that's not what I want to capture. Hold on. All right, I've got all of us in there. Thank you so much for your time today. And have a great weekend. Those of you who are going to watch football, some teams are losing, some are winning. I wish you all the best with your teams. And for the rest of us, we're just going to chill because it's Saturday. Peace out. Thank you. Thank you.
Bye, everyone.
Thank
Thank you.
you.